So my inspiration for getting into electronics was really, I actually started in computing really when I was younger. I got this kind of idea that if I knew how to do computing and stuff like that, I could make the device do what I wanted to do. And back then I really wanted to just make games. So I went to the library and got out a book. Heaven forbid nowadays, you know, everyone just uses Google. But yeah, no, so I got out a book on computing and went from there really. I've been quite involved in outreach stuff, and my proudest project really is a thing I put together with the microbit that we've then taken out into, I think we've been to 12 different schools now. The challenge was, how do we put together a project that kids can do in a classroom in a 2-hour period, but also that actually teaches them sufficient technical detail that they get something out of it and that they can see, you know, the coding in their learning and the electronics as well, the actual wiring. To then use that in their later kind of home or whatever. I'm about to start on a PhD to look at an idea I've been working on with my supervisor at the university. That's in hardware, so we're doing a whole new form of processor, because processors haven't really changed since the 1980s, so we're trying to kind of step that forward in a big way. If that's successful, I might well start a startup company and then try and push that out into the market. So 10 years from now, I could be heading up a nice new silicon company. Security and power are the two main motivations for this. Software is using increasingly complex memory structures that the hardware doesn't really support. The hardware's not changed since about 1980 in terms of, but the languages have moved along. So if we can make the hardware match the software's view of the world, then we can actually massively improve power efficiency. And security, we're seeing more and more Internet of Things devices. Most of those not really very secure. We're seeing more and more attacks, and actually trying to support the level of security you need in software is very, very difficult. You know, Imagination Technologies and Intel and people like that have been working on hypervisor style stuff. We're actually hoping to say you don't need that, you can do it using this kind of object-oriented memory model that gives you all the security you need. My favorite at the moment, and it is kind of a classic, is the driverless car stuff. You know, on the roads you can't control other drivers. I like the idea that I can sit in a car where they're all operating, and I'm not going to get hit by someone else because I know that they're all operating in the same way, and that's quite controlled. And I like the idea that you can remove the steering wheel, because then everyone can sit in kind of a circle in their car. I'd like to see a car that's actually round. So just changing that kind of, car journeys can become more social in that aspect. That's an exciting area. The UK is in an interesting position. Obviously we've got a lot of things going on at the moment, dare I say it, Brexit, and stuff like that. So what we really need is investment. We've got a lot of finance industry, but a lot of them are investing in these kind of stock markets and financial constructs. What we really need is investment in startup companies to support our engineers and to actually just throw money at ideas and see which ones work, which ones stick, and we'll lose some money along the way somewhere, but we'll find some engineering companies that are really successful, and hopefully we can hang on to them. We're losing a lot of companies to Silicon Valley and possibly to Europe in the future and other places. We need to be trying to value our engineers more and actually holding on to them in this country and the companies around them as well.